In chapter 7.3, we'll be doing hypothesis testing for the population mean again, except this time the population standard deviation will not be known. So if sigma is not given to us, the population standard deviation, we use a t-test. So that means we'll be using the test statistic t, which is this little formula here, x bar minus mu divided by s over the square root of the sample size, where s is the standard deviation of the sample. Okay, so the steps for doing the t-test here, first we have to verify that sigma is not given to us, and then we have to state the hypotheses again. So we have to state the null and the alternative hypotheses, same way we did it before. And we should identify the level of significance, which will be given to us in the problem, which is alpha. And since we're doing a t-test, we need the degrees of freedom, which is n minus 1, and we need that for the table. And we're going to find the critical value, which we'll call t sub 0, and we find that from the table using alpha and the degrees of freedom. Okay, so I'll bring up the table in 1 second. So for the distribution, for the t-distribution, what we should do is we should graph it, drawing the bell curve, and we should shade in the proper region. So if it's a left-tailed test, that's going to be the area to the left of negative t that we found on the table. So left-tailed is area to the left of negative t, right-tailed is area to the right of positive t, and two-tailed is going to be the area left of negative t and right of positive t. So we're going to shade in those regions on the table. So before I finish this off, let's take a look at the table real quick. So now we're going to be using these two bottom rows right here. So one tail represents a left tail, this one right here. This represents left tail or right tail alpha. Two tail obviously represents two tail alpha. So we have to make sure we're using the right row for that, and then we just use degrees of freedom to find our t sub 0 value inside here. And these graphs over here are how we're going to be shading them in when we are doing these problems. Okay, so back to the steps for this. So the next step is to calculate the standardized test statistic. So that's going to be using this t-score up here. And what we're essentially doing is comparing the t-value that we calculate to the t-value in the table. So we're going to go back up to the graph that we shaded in, and for step 8 here, if the t-value falls within the shaded region of the graph, we reject the null. If not, then we fail to reject the null. And then once again, we're going to come up with a concluding statement in terms of the original claim. Okay, so pretty complicated, a lot of steps here. And we're doing this, as you can tell, a little bit differently than how we did it with the z-test. So let's do 3 examples of each kind of test here. So a used car dealer says that the mean price of a used car is at least $20,500. So right away, here's the claim. The claim is that mu is at least, that means greater than or equal to 20,500. So automatically we know that that's going to be the null because there is equality in there. So you think this information is incorrect, and you get a sample of 14 cars and find that it has a mean price of $19,850, and the standard deviation of the sample is 1,084. So we want to know, is there enough evidence to reject the dealer's claim at a significance level of 0.05? Okay, so let's just start writing down the givens here. So we have the sample size is 14. The sample standard deviation is 1,084. The sample mean is 19,850. And the significance level is 0.05. Okay, so let's start doing these steps. So the first step is that we have sigma is unknown. So that means we'll be doing a t-test So we have the standard deviation for the sample, but we do not have it for the population, so t-test. And step 2, let's come up with these hypotheses. So we said that the null was the claim because it was equality. So the null is mu greater than or equal to 20,500, and that is the claim. Let's switch that to blue, and that means the alternative is going to be the opposite of that. So instead of greater than or equal to, it is just less than. And automatically, I'm going to say this is a left-tailed test because the alternative says less than. So that means we're going to be shading in an area to the left. So we have to find the t-value now. So this is going to be from the table. So this is going to be the t sub 0 value, the critical value t. So for that, we need alpha, and we need the degrees of freedom. So alpha is given to us, it's 0.05. Degrees of freedom is the sample size minus 1. The sample size was 14. So it's 14 minus 1, which is 13. And now going to the table. So this is a one-tail test because it was just a left tail. So here is 0.05 and degrees of freedom 13 right here. So they meet right down here at 1.771. So that is going to be our t-value. But the thing that's difficult here that you just have to remember is that since it's a left-tailed test, we are doing the area, shading in the area to the left of negative 1.771. So for the t-test, if we're doing an area to the left, we have to make the t-value negative and shade in the area to the left of the negative version. So negative 1.771, and it's going to be the area to the left. So now what we have to do is calculate the standardized test statistic, which is like the t-score, and we have to see if the t-score falls within the interval to the left of negative 1.771. So that's going to be t equals x bar minus mu over s divided by the square root of n. So we have all these numbers from the problem. They were given to us, so we plugged them all in. And we end up getting the t-score is negative 2.244. So once we get that, we go back up here to our graph. Negative 2.244 is going to be over here somewhere. Doesn't have to be perfect. All we care about is that it's in the shaded region. Since it is in the shaded region, that means we're going to reject the null. So anytime we are rejecting the null, that means we're accepting the alternative. So now we have to word this in terms of the actual problem here. So the claim was the null in this case. So we are actually rejecting the null, which means we're rejecting the claim. So we could start by saying there is enough evidence at the 5% level of significance to reject the claim in this case. So we're doing the same conclusion setup as we did for the last section. So there's enough evidence to reject the claim, and then let's just repeat the claim in words in terms of what the claim actually was. The claim was that the mean price of a used car is at least $20,500. And we're accepting the alternative. The alternative said that mu is less than 20,500. So that means we're going to accept that it's less than $20,500. Okay, so we concluded that the claim at the 5% level of significance, so that's just our alpha, we could reject that claim and accept the alternative. Okay, so that was a left tail. Let's do another one. So an insurance agent says that the mean cost of insuring a car is more than $1,200. So once again, this is the claim. More than is greater than, so mu greater than 1,200. A random sample of 7, so n is 7. Random sample of 7 cars has a mean cost cost of insuring here, cost of insuring of 1,275, so that is our X bar, that's our sample mean, with a standard deviation, a sample standard deviation of 55. We want to know, is there enough evidence to support the claim at a significance level of 10% or 0.1. Okay, so let's start this off by verifying that we don't have the population standard deviation. So that means this will be a t-test. And next, let's set up these hypotheses. So we have the null, we have the alternative. So the claim was mu greater than 1200. There's no equality, so that has to be the alternative. So that's our claim. The null is going to be the opposite of that, so it's going to be less than or equal to 1200. Okay, so once again, let's look right at the alternative right now and notice, based on the fact that it's greater than, this is a right-tailed test. And now we have to find the critical value on the table. So we need alpha and the degrees of freedom. So alpha is 0.1. The degrees of freedom is n minus 1, which is 7 minus 1, so that is 6. So looking at the table here, we have a one-tail test again. So it's one tail and the alpha was 0.1. Degrees of freedom was 6. So that's going to be a value of 1.44 for our t-value. Okay, so that's going to be a critical value of 1.44. So we are doing a right-tail test. Since it's a right-tail test, the area that we're filling in is the area to the right of positive 1.44. Okay, so we go up to the table here and we just put 1.44 to somewhere to the right of 0, and we shade in the area to the right of this. So now we're going to calculate the t-score here, that standardized test statistic, and see if it falls within that region again. Okay, so that's going to be this formula once again. So we fill in everything that we already are given. So that's 1,275 minus 1,200 over 55 over the square root of 7, square root of 7, not 14. Okay, so plugging this in, this gives us a t-value of 3.61. So we need to go to the table now. And 3.61 is definitely all the way over here somewhere. So that is in the shaded region. So once again, since it's in the shaded region, we reject the null. So for the conclusion, since our t-value, our test statistic, is in the shaded region, we reject the null and accept the alternative. So let's say this in words again. So we are rejecting the null and accepting the alternative. The claim was the alternative, so we are accepting the claim here. So we can say there is enough evidence at the 10% level of significance to support the claim. And then we'll say what the claim was in words. The claim is the alternative. The alternative said that mu is greater than 1,200, so we can support the claim that the mean cost is more than $1,200. Okay, so let's do one more here. So we have a company claims that the mean pH level of water in a river is 6.8. You randomly select 29 water samples from the river and measure the pH of each sample. The sample mean and standard deviation are 6.7 and 0.35. We want to know if there's enough evidence to reject the claim at a significance level of 0.05. Okay, so that first sentence, we have the claim. The claim is mu equals 6.8. So the claim was that the pH is 6.8. So that's mu equals 6.8. So automatically we should be expecting a two-tailed test. So we selected 29 samples, so that's the sample size. And we found the sample mean was 6.7, which was less than the claim. And the sample standard deviation was 0.35. And the significance level was 0.05. Okay, so for the first step here, we don't have the population standard deviation, so we know that we're doing a t-test. And let's set up these hypotheses. So for the null and the alternative, we go back up to our claim. Our claim was that mu equals 6.8. Since there is equality, that has to be the null. So the null is the claim this time. And if that's the null, then that means the alternative is not equal to 6.8. Okay, and then we can determine what kind of test we're doing. Since it's not equal to for the alternative, it is going to be a two-tailed test. And now let's find the critical value t from the table. Okay, so we have alpha is 0.05, degrees of freedom, sample size -1, which is 28. So finding this in the table now, we have to be careful because now we're doing a two-tailed test. So that's going to be this row. So two-tailed test of 0.05 would be right here. And the degrees of freedom being 28 are down here. So that's the middle column. So that's going to be this value right here, 2.048. So that is our critical value t. And since we're doing a two-tailed test, we're going to be shading in the region to the left of negative t and to the right of positive t. So going up here on the graph, we're going to put positive 2.048 over here, and then negative 2.048 somewhere over here, and shade in the area to the left of this one, and the area to the right of this one. And now we're going to calculate the t-value, the standardized test statistic, and see if it lies within that shaded region. So using our formula here, we're going to have the sample mean minus the hypothesized mean over the standard deviation divided by the square root of the sample size. Okay, so this will give us, plugging this in, this gives us a t-value of negative 1.53. And we go back up here to our graph. Negative 1.53 is somewhere over here. So this is clearly not in the shaded region. So since that is not in the shaded region, we fail to reject the null hypothesis. So for the conclusion now, we can say since the t-value that we found is not in the shaded region, we fail to reject the null. So remember, that never means we're accepting the null hypothesis. We never accept it. We just failed to reject it. So now for writing the conclusion in terms of the problem. So we can say since we failed to reject it, we would say there's not enough evidence at the 5% level of significance to reject the claim because the claim was the null. So there's not enough evidence to reject the claim, and then we say it in words, to reject the claim that the mean pH level is 6.8. So we were just unable to prove that claim wrong at this certain significance level based on our data. Okay, so that would be how we write the conclusion for this one. So it could be right, it could be wrong. All we did was fail to reject it, fail to prove them wrong at this level of significance. Okay, so that is it for 7.3.